Scientists just discovered time travel might actually be possible. But what would really happen if you changed history?
Would you save the dinosaurs, prevent a world war, or maybe meet your future self? Today, we're diving deep into the fascinating science of time travel, what Einstein, wormholes, and quantum physics tell us, and the strange paradoxes that could decide the fate of the universe.
Time travel sounds like pure science fiction. But believe it or not, physics already gives us hints that it may be possible. Let's start with Einstein's theory of relativity. Einstein showed us that space and time are not separate things. They're woven together into a single fabric called space-time. And here's the strange part. Space-time can stretch, bend, and warp. If you move extremely fast, close to the speed of light, time itself slows down for you. This is called time dilation. For example, astronauts orbiting Earth on the International Space Station actually age just a little bit slower than people on the ground. The difference is tiny, but measurable. So, traveling into the future is not only possible, it's already happening. The faster you move or the stronger the gravity you're near, the more time bends. But what about traveling into the past? That's where things get much more complicated. Some scientists think wormholes, theoretical tunnels through space-time, could allow shortcuts between two different moments in history. Imagine folding a piece of paper and punching a hole through it. Suddenly, point A and point B are connected. Quantum mechanics also plays a role. At the smallest scales, particles exist in multiple states at once until observed. Some researchers believe this opens the door to parallel timelines, alternate realities where every possibility exists. If true, traveling back in time might not break reality at all. Instead, you'd simply jump into another universe. So physics does not slam the door shut on time travel, but it does raise some mind-bending questions.
Let's explore what would actually happen if time travel was real. The grandfather paradox. This is the most famous. Imagine you go back in time and accidentally prevent your grandfather from meeting your grandmother. That means you would never be born. But if you were never born, how could you go back to stop them in the first place? This logical loop is called the grandfather paradox. Many scientists think it shows backward time travel is impossible. Others argue the universe would prevent you from making such a change in the first place, forcing history to self-correct. The butterfly effect. Now imagine something smaller. You step on a butterfly millions of years ago. That tiny action ripples forward through history, eventually changing the entire course of civilization. Maybe the country you live in doesn't even exist anymore. This idea is called the butterfly effect, and it reminds us how sensitive history can be to the smallest changes. Alternate timelines. But there's another possibility. What if changing the past doesn't affect your present at all? Instead, it might create an alternate branch of reality. In this version of events, if you went back and saved the dinosaurs, your original timeline would continue without you. But a new parallel universe would be born, where dinosaurs roam the Earth today. This is the essence of the many worlds interpretation of quantum mechanics. Every choice, every action spawns a new universe, and time travel could simply be jumping tracks, the Novikov principle. Finally, there's the Novikov self-consistency principle. This theory says the past can't be changed. If you go back, everything you do already happened. So even if you tried to prevent World War II, your actions would end up being the reason it started in the first place. So, could you actually change the past, or would the universe stop you? Here's what science suggests. Traveling to the future is already proven by relativity. Traveling to the past might be possible with wormholes, but paradoxes make it extremely unstable. If parallel universes exist, then changing history might simply mean creating a brand new timeline. Or, if the Novikov principle is true, then history is unbreakable. You can only ever play your destined role. Time travel may never leave the realm of theory. But one thing is clear. Just asking "what if" changes the way we understand reality, free will, and the very meaning of history. For almost all of history, time travel was pure fantasy, something you'd only find in books or movies. But then, at the start of the 20th century, one man completely shattered our view of reality, and, in doing so, accidentally cracked open the door to time travel as a real scientific idea. That man, of course, was Albert Einstein. Before Einstein, everyone thought the universe ran on one predictable clock. Time was absolute, ticking at the same speed for everyone, everywhere. But Einstein's theories of special and general relativity tossed that idea right out the window. He showed us something incredible. Time isn't separate from space, emphasize. They're actually woven together into a four-dimensional fabric called space-time. The easiest way to picture this is to imagine space-time as a huge, stretchy rubber sheet visual. Heavy things, like planets and stars, create dips and curves in it. What we feel as gravity, Einstein explained, isn't some mysterious force. It's just us moving along the curves in space-time created by Earth's mass. But here's where it gets really weird. This fabric doesn't just bend space, it also messes with the flow of time. And this isn't just a theory, it's a proven, measurable fact you use every single day, probably without even thinking about it. GPS, the Global Positioning System, relies on satellites orbiting Earth at about 14,000 kilometers per hour, far from the strongest pull of Earth's gravity. According to Einstein's special relativity, the faster you move, the slower time passes for you, compared to someone standing still. From our point of view, this means the clocks on those fast-moving satellites tick about 7 microseconds slower every day. But that's only half of it. Slight tension. General relativity adds another layer, predicting that time also slows down in stronger gravity. Since the satellites are in a weaker gravitational field than we are, their clocks actually tick faster than ours. By about 45 microseconds a day. Combine the two effects, and the clocks on GPS satellites run ahead of ours by 38 microseconds daily. It doesn't sound like much, but if engineers didn't correct for this, your GPS would be off by about 10 kilometers every single day, making it totally useless in minutes. This effect, called time dilation, proves that time isn't fixed, it's flexible, and it confirms an incredible truth. Traveling to the future is theoretically possible. If you were to board a spaceship, travel close to the speed of light for what feels like a year to you, you could return to an Earth where decades, or even centuries, have passed. You would have jumped into the future, but that's only one direction. To go backward, we'd need to do more than just bend time. We'd need to find a way to punch a hole right through it.